daily integral challenge. Today we're going to take a look at sine x times cosine x dx, and I'm going to stop the timer right here. Alright, so we're going to approach this integral in two different ways. First, we're going to let f be equal to sine of x, which means g prime is equal to cosine of x. This will lead us to f prime being equal to cosine of x and g being equal to sine of x. Okay, now we're gonna do integration by parts. We have to multiply f times g, which means we have sine x times sine of x minus the integral of sine x, which is our g, times our f prime, which is cosine of x dx. And now if we look closely, we see that the integral on the front, which I will call I, reappears on the back. Which means I is equal to sine, let me multiply these two together, sine squared of x minus I. Alright, now what we're going to do is we're going to add I on both sides. So we get 2I is equal to sine squared of x, and then we're going to divide by 2 on both sides, and we get I is equal to 1/2 times sine squared of x. Okay, but now we're gonna take a different approach to the exact same integral. Let me draw a line here. Okay. So I arbitrarily chose f to be sine of x and g prime to be cosine of x, but we could have done it the other way around. So we have sine of x times cosine of x dx is equal to, alright, let's do it the other way around. We choose f to be equal of cosine of x this time, and we choose g prime to be the sine of x, which gives us f prime, which is equal to negative sine of x, and g to be the negative cosine of x. And again, we're doing integration by parts, which means we're gonna end up with g prime. Oh, no, not g prime. We're gonna have g times f. Okay, so we have negative cosine of x times the cosine of x minus the integral of, and now we have g times f prime, and the minus and minus will cancel out to plus, so we just have sine of x times cosine of x dx. Alrighty, again, same approach as before. We have this integral here be equal to I, and we have the integral again back over here. We let this be equal to I as well. So we have I is equal to negative cosine squared of x minus our I. And again, I'm going to add I on both sides, and I'm ending up with 2I is equal to negative cosine squared of x. I'm going to divide both sides by 2, and the value for the integral will be 1 over 2, well, let me put the negative into the front, minus 1 over 2 times the cosine squared of x. Okay, so now we have two different values for the same integral. How can that be? We did the same things on both sides, but they're definitely not the same thing. You see, here we have a sine, here we have a cosine, here we have a factor of minus a half, here we have a factor of a half. So what I'm going to do is I use my little applet right here, and I'm going to graph both of those. So if I take a look at them, let me swap those around, by the way. Whoop. Okay, so if I take a look at those, this one is 1/2 times the sine squared of x. But what does that mean? So we go down to 0, and then we go up to 1 by pi half, and we go up to a half by pi halves, etc. And that's when the sine wave starts to repeat. Down here we have a similar situation, but instead at 0 we go down to negative 1/2. So what is the mistake? Those are two different graphs. However, if I take the slower graph and I added it around a bit, which means I'm taking this and I'm going to add 0.5 to it, suddenly we have the same graph as we have above, just not zoomed in the same way. So why is that the case? Well, it's rather simple, because I left out an important part that I forgot a couple videos before already, which is our plus c. Both those integrals are actually the same, they are just shifted in the y direction, and the plus c back here is responsible for that shift into the y direction. So what I'm going to look at here is I'm taking this graph here, and if I shift it around into the y direction, I'm going to end up with the same graph as below, which means our integral is actually correct after all. Alright, that's basically the video. If you have any questions about the topic, let me know in the comments, and I'll see you in the next one.